So, today we're going to be doing an example problem of kinematics. And kinematics is the study and description of motion without regard to its causes. It can be studied without regard to mass or physical quantities related to mass. In this problem, we will be dealing with position, velocity, time, and acceleration. So, the problem is that in a classic Seinfeld episode, Jerry races one of his old high school friends. Upon hearing a car backfire, Jerry leaves half a second before his friend. Jerry's maximum acceleration is 2 meters per second, and his friend's is 2.2 meters per second. So, before we start with any of the problems, let's write down what we know. We know that Jerry's acceleration, 2 meters per second. We know that Jerry's friend, the acceleration of Jerry's friend, is 2.2 meters per second, is time of Jerry's friend plus 0.5 seconds. So, we're going to find how long it will take the friend to overtake Jerry. So, we are going to find, what we're trying to find is time of the friend when the final position of Jerry is equal to the final position of Jerry's friend. So, let's use the equation the initial position plus the initial velocity times the time plus the acceleration times time squared over 2 equals the final position. And that's the equation we're going to be using to find how long it will take the friend to overtake Jerry. We're going to find this when this part for Jerry is equal to that part for his friend. So the equation is going to look like position initial Jerry plus velocity initial Jerry times Jerry's time plus Jerry's acceleration times Jerry's time squared over 2 is equal to the initial position of his friend plus his initial velocity times his time plus his acceleration times his time squared over 2. But we know that both of their initial positions are 0 because they both start at 0, and their velocities are also 0, so these both cancel out. And now we can rewrite the equation and substitute in what we know. So we know that Jerry's acceleration is 2 meters per second times his time squared over 2 is equal to 2.2 meters per second times Jerry's friend's time over 2. So, now we know that time of Jerry is equal to this, so we're going to plug that into the equation. And we're going to get 2 meters per second times this, time of Jerry's friend, time of Jerry's friend plus 5 seconds squared over 2 is going to be equal to 2.2 meters per second times Jerry's friend's time squared over 2. Now, we can simplify this and cancel these out, and cancel this out, and this is 1.1. So, then, when we expand the equation, we get time of Jerry's friend squared plus time of Jerry's friend plus 0.25 equals 1.1 time friend squared. Now, solving for time friend, we move this over to this side, and we get, and then we solve for TF, and we get that TF f is equal to negative 0.24 seconds or 10.24 seconds. So, we know that negative 2.24 seconds isn't a possible answer, so we can eliminate it, and we get that the time of Jerry's friend when he overtakes Jerry is after 10.24 seconds. So, next we're going to find how far from the start they are. So we know that time of friend is 10.24 seconds. So, next we're going to find how far from the start they are when they're even. So we're going to use that same equation. The position final of the friend is equal to the initial position of the friend plus the initial velocity of the friend times the friend's time plus the acceleration of the friend times the time squared over 2. So that's the equation that we're going to use. Now we know that his position is still 0 and the velocity is still 0, so both of those are gone. And then so we know that the acceleration of the friend is 2.2 meters per second, and that we now know that his time is 10.24 seconds, so squared and then over 2. So when we get that the final position of Jerry's friend is equal to 115.34 meters. Now, and since they're equal, that's both of their positions, so they're both equal to 115. So now we're going to find the velocities of Jerry and his friend when they are even. So, we know that the final velocity is equal to the initial velocity plus the acceleration times time. So, we know that for the final velocity of the friend, we know that the initial velocity is 0, and we know that his acceleration is 2.2 meters per second, and his time is 10.24 seconds. So, the initial velocity of the friend you just multiply that across and you get the initial velocity is 22.53 meters per second. So, and now for the final velocity of Jerry, we have that it's equal to the initial velocity of Jerry plus Jerry's acceleration times Jerry's time. And we know that velocity is 0, the initial velocity is 0, and we know that the acceleration is 2 meters per second, and we know that Jerry's time is, so time Jerry is equal to time of his friend plus 0.5 seconds. And we know that the time of his friend is equal to 10.24 seconds, so plus 0.5 seconds, and we get that Jerry's velocity, or time, is equal to 10.74 seconds. So we substitute that in, 10.74 seconds, and we get that his final velocity, when they are equal, is 21.48 meters per second. So that is how an example problem for one-dimensional kinematics.